the impossible physics of water walking. At first glance, walking on water feels like something that belongs purely to mythology or magic. Humans sink, objects sink, and water clearly does not behave like a solid surface. Yet nature quietly breaks this rule every day. Tiny insects skate across ponds, lizards sprint over rivers, and even humans can briefly run on water under the right conditions. The secret is not magic, it is physics, and surprisingly clever physics at that. Understanding how water walking works reveals just how flexible the laws of nature really are and why what seems impossible is often just misunderstood. Water behaves differently, depending on scale and speed. At rest, water flows easily and yields under pressure, which is why we sink when we stand still. But at very small scales, water has a property called surface tension. Water molecules attract each other strongly, forming an elastic-like skin at the surface. This invisible membrane is strong enough to support small, lightweight creatures if their weight is spread out carefully. Water striders, for example, use long hydrophobic legs that distribute their weight over a wide area. Instead of breaking the surface, their legs dent it slightly, creating tiny bowls of tension that push back upward. For them, water behaves less like a liquid and more like a stretched trampoline. Speed adds another layer to the illusion. When an object hits water quickly, the water does not have time to move aside. Instead, it resists, behaving almost like a solid for a split second. This is the principle behind belly-flopping, pain-skipping stones and high-speed water walking. The basilisk lizard, often called the Jesus lizard, uses this trick perfectly. It slaps its large feet against the water at incredible speed, trapping pockets of air and pushing water downward with enough force to keep its body above the surface. Each step creates a brief upward thrust just long enough for the next step to land. Humans too can exploit this effect, though only barely. When we run across shallow water or try water walking demonstrations with special equipment, success depends on speed, foot shape, and force. Our feet are relatively small compared to our body mass, and we cannot move them fast enough to generate sustained upward force. Physics shows that for a human to truly run on water unaided, they would need to strike the surface several times per second with enormous force, far beyond what muscles and bones can safely handle. In other words, the laws of physics do not forbid water walking for humans. It is our biology that sets the limit. The real beauty of water walking lies in how it blends different areas of physics. Surface tension dominates. At small scales, inertia and momentum take over at high speeds, and gravity constantly pulls everything downward. Nature selects solutions that balance these forces efficiently. Light bodies, wide contact areas, rapid motion, and clever use of air all contribute to the illusion of defying gravity. Nothing is actually being broken, the rules are simply being used to their fullest extent. This idea challenges how we think about impossible phenomena. Water walking feels impossible because our everyday experience is limited to slow movement and large body sizes. Change the scale, change the speed, or change the interaction, and reality looks completely different. The same water that swallows a standing human becomes a solid-like surface to an insect and a temporary runway to a sprinting lizard. In the end, the physics of water walking teaches us a powerful lesson. Nature does not rely on exceptions, it relies on precision. The world is full of hidden rules that only reveal themselves when conditions are just right. What looks like a miracle is often just physics working quietly in the background, waiting for us to notice. If this article changed the way you see water and the laws of nature, don't forget to like, share, and subscribe for more mind-blowing science explained in a simple and fascinating way.